In this project, we construct a corpus of cues composed by Koji Kondo and drawn from Nintendo's Super Mario and Legend of Zelda franchises in order to explore the relationship between macroharmony and gameplay function. We compile an online repository of transcriptions and subjectively tag them with descriptions relating to three gameplay functions. We then apply Ian Quinn's application of the discrete Fourier transform, or DFT, on pitch class collections to capture their macroharmonic quality so that we can explore the degree to which harmonic features overlap with the subjective categorization.
We obtained the cues from ninsheetmusic.org, a repository of transcriptions of Nintendo franchise video game cues made by fans. Each cue includes its sheet music format and MIDI data. We intentionally chose music by a single composer, Koji Kondo, so that we could explore how the same composer approached two radically different franchises in terms of gameplay environment. To create the corpus, we chose 5 games from each of the franchises. For each, we downloaded the corresponding MIDI files, excluded cues below a certain popularity rating of yellow, and ensured each cue was accurately transcribed. Additionally, we only considered cues that serve as an underscoring to the game environment, so excluding exceedingly short cues, those shorter than 3 measures, or those that functioned unequivocally as sound effects. These short sound bites are known as ear cons and do not function as underscoring. So in total, we extracted 234 cues.
Next, we sought a categorization scheme for the cues that could capture the music's role as but one component of an immersive game space. To this end, we tagged each cue according to 3 of Winifred Phillips' functions of game music, namely music as a state of mind, music as world builder, and music as a pace setter. With regard to state of mind, music helps transport the player's mental state to an affective zone in which they are immersed in solving the challenges of the game. Regarding world builder, Phillips states that, quote, games have the marvelous ability to transport us to fantastic landscapes of the imagination, end quote. An RPG such as Zelda entails great freedom for the player to explore the open world in a non-linear fashion. While lacking this total freedom, Mario games still inhabit an eclectic environment in the way Kondo combines timbres, rhythms, and other parameters from a wide variety of styles in order to create the depiction of a plumber jumping around on turtle shells. Finally, music functions as a pace setter in that it must reflect the energy level of the gameplay. It infuses the game with an overall momentum which unifies higher and lower energy moments, particularly in action and adventure games. In order to cluster cues with similar attributes, we tagged each cue with a range of descriptors for each function, such as peace or anxiety for state of mind, dungeon or safety for world builder, and active or not urgent for pace setter, to name just a few. So far, we have tagged the gameplay functions for 3 games in each franchise, with a total of 133 cues. These functions are themselves complex, built up from a combination of musical parameters and interacting with myriad visual and gameplay elements. This constitutes a significant challenge to building this corpus, which is to discretely and succinctly describe the cues in terms of these functions in order to compare them fruitfully and efficiently. On the other hand, the complexity of these functions may prove to be a strength of the corpus in that they invite a wide array of comparisons.
The 3 gameplay functions serve as ground truths to measure the DFT's ability to identify macroharmonic similarity and test our assumption that cues with similar functions have similar macroharmonic profiles. So, hypothetically, clusters should group together by categories if our methodology is a good method. In other words, we're presuming that these encoded features have some harmonic similarity, and we use the pitch class Fourier transform as a quantitative metric to test this presumption. In our case, the discrete Fourier transform, henceforth DFT, takes a vector of pitch class frequencies and returns a sinusoidal decomposition of the vector. So, for example, we would encode all the pitches shown here in a pitch class vector. C's get filed into the first index position. There aren't any D's, and any C sharps get moved into the next position, and so on and so forth. The DFT of that vector returns 6 non-trivial equal divisions of the octave, F1 to F6. The magnitude for each of those components, shown here, captures how well a pitch class distribution fits into the given division of that space. In the actual study, these values were normalized to account for pitch class cardinality. Okay, but what did these values mean? In 2006 and 2007, Quinn showed that the DFT components can be used to describe harmonic quality given pitch class sets. Since its reintroduction to music theory, the DFT has been used for other purposes in music theory, but most regarding quality, style, and analysis. In this paper, we'll build on my most recent MTO article and use the DFT to study larger macroharmonic collections. When analyzing larger pitch class collections, we can say that each component is associated with a macroharmonic quality. The higher the magnitude value, the more the collection elicits the respective quality. The qualities are clustered quality, dyadicity, hexatonicity or triadicity, octatonicity, diatonicity, and whole tone quality, respectively. The first component, clustered quality, is notated F1, the second component is notated F2, and so on. There's actually a bit more nuance to the qualities than this one-to-one correspondent that we won't have time for here, but maybe we can Q&A, or you can email us. So, in order to extract macroharmonies, we used overlapping sliding windows of pitch classes, imitating the experience of listening. Just as we take in pitch information and process it while listening to a piece, we can tell a computer to take a window spanning a certain number of beats and slide it through the score. That way, we retrieve pitch class distributions. We use a window of 6 quarter notes that skip every 2 quarter notes. We then took the DFT of each of those windows and then we averaged those DFTs to get a single DFT array. In other words, each piece was represented by this single average DFT. So using these average DFTs and the qualitative tags, we ran 3 experiments. This is all exploratory and ongoing, so we welcome any comments or ideas on additional tests to run.
In the first experiment, we looked solely at the DFTs, ignoring the tags. First, we compared DFTs from one queue to the other queues within the same game. Then, we compared each queue to every other queue in the same franchise, essentially a between-within experiment where each game is the condition. The left columns show average distances within each game, and the right columns show the average distances between games in the same franchise. We were struck that the distance within a game for Zelda queues hardly differed from the between comparison, suggesting a relatively high degree of variety within individual Zelda games. The greater difference between within and between comparisons in the Mario franchise suggests that within a single Mario game there is much more ubiquity. These results reinforce genre-specific aspects of the franchises as role-playing games and platformers, respectively. We would expect the open world of Zelda to include a broader musical language to portray its diverse cultures and locations, whereas the linear, more homogeneous nature of a platformer might incorporate more homogeneous music. In the second experiment, we clustered queues according to whether or not their descriptors with respect to each function overlapped. Overlapping queues shared a tag such as anxiety or peace for state of mind, dungeon or town for world builder, and so on. Non-overlapping queues did not share descriptors. Overlapping queues for each function in both franchises had closer DFTs, suggesting that the DFT can indicate functional similarities. This offers some confirmation of our presumption that macroharmony and gameplay function are related. We are also intrigued by the relatively greater distances between overlapping and non-overlapping cues in Mario as opposed to Zelda, as this could suggest that overlapping music in Mario sticks to a more limited harmonic language.
In the third experiment, we chose to examine specific clusters within a functional category. In this case, danger versus safety in Zelda and happy versus scared in Mario in the state of mind category. Cues marked with safety in Zelda are more diatonic, confirming our presumption that such cues, often comprising simple tonal melodies and harmonies, would be more diatonic. On the other hand, cues marked with danger are more varied with the DFT. With Mario, we obtained an analogous result in which happy cues are more diatonic and scared cues are more varied. Scared and danger have relatively flat distributions, meaning that lots of qualities might be captured, such as pervasive chromaticism or frequent modulations. An interesting comparison emerges between franchises with respect to diatonicity and triadicity. Although both Zelda and Mario have spikes at F5 in terms of safety and happy, Mario has a greater spike in F3 relative to Zelda. This more pronounced combination of F5 and F3 suggests that Mario is more triadic than Zelda, even though Zelda is quite diatonic. This could potentially reflect the presence of more diatonic music in Zelda that is not organized or harmonized triadically.
As we continue this project, we will tag the remaining games in the corpus with gameplay function descriptions. In terms of additional hermeneutic measures, we want to consider Philip's other functions such as music as demarcation. We might also tag cues according to their relationship to interactive affordances. In terms of music analysis, we can consider cues' tonalities or key centers, meter, and tempo in relation to gameplay function. We might also encode harmonic or cadential analyses. In summary, although the DFT appears to have in fact captured gameplay function through macroharmonic content, we're interested in applying other analytical methods or metrics. Thank you for attending our presentation. We welcome any comments, questions, or suggestions as we continue our work.